In this video, we're going to work the example problems from section 5.2, which was on calculating areas under the normal curve. And what we talked about in the previous video was that instead of using the traditional method that's taught in statistics classes where it's graphical, so you calculate they call it a z-score, which is just you calculate the standard units of a, you have your own histogram, and you want to calculate the area between 2 points on the histogram. If you're assuming that histogram is distributed as normally distributed, then you convert either one or two of the points that you want to find the area between into a z-score, which is just into standard units. How many standard deviations that point is away from the average. And when I say 1 or 2 points, what I mean is, you might want the area just between 0 and a point, or between 0 and the negative of that point, or between plus or minus that same z value. So then you just need one. You just calculate one z-score. But you might want the area between like here and here. So you need to calculate the 2 z-scores. Okay, we talked about how the traditional method in the previous video. We talked about the traditional method is you get the z-scores and you use this table here, which gives you the area between plus or minus z. You can use this table to calculate the area under close to any interval you want by just using some tricks of summing and subtracting different areas. So that's the traditional method. But what I mentioned in the previous video is that in this course, we're not going to use that method. The method that we're going to use is faster, more intuitive, and it's more versatile than this graphical method, because we saw here that there's some scenarios where you're going to have to get an approximate the area under the curve, like between 1 and 2 here. You're going to have to get, it'll be a good approximation, but approximate it. We can get the exact area easily. And we do this using the formula for the normal curve, this formula. Okay, I went into the details and specifics of this in the previous video, so go watch that video if you need, but let's go ahead and put this formula into our graphing calculator. And you can do this with all this stuff we're going to do here. You can do this with any graphing calculator. So okay, now we're going to store this as an equation. Okay, there we go. Okay, number 1, find the area under the normal curve to the right of 1.25. So to the right of 1.25, that means we want to, so we're going to integrate e with respect to x so to the right of 1.25, that's going to be, the top limit is going to be infinity. And then 1.25. So from 1.25 to infinity. So 10.6%. Okay, to the left of minus 0.4. So we're going to go from, the upper limit is minus 0.4. The lower limit is minus infinity. %34.5%. Okay, to the left of 0.8. To the left of 0.8, so just the upper limit is 0.8. %78.8%. See how easy this is? Okay, between 0.4 and 1.3. 24.8%. Between minus 0.3 and 0.9. (43.4%). Outside minus 1.5 to 1.5. Okay. So what they're saying is, so this is 0. This is, let's say this is 1.5. They're saying like this. So how do you do that? Well, you would do, so minus 1.5 to negative infinity. Okay, and then 1.5 to infinity, and then just add those two. And I mean, it's symmetric, so we could just multiply this by 2. But 13.4%. Fill in the blanks. The area between plus or minus blank under the normal curve equals 68%. All right, so yeah, in the previous video, I didn't talk about this. But yeah, if you want to go in reverse, so you have you're given an area, but you want to find the z-score. So how do we do that with the calculator? All right, well, what you do is, and again, any graphing calculator can do this. So we've got the equation. You use the solve feature. So you say here, if we want to calculate what's the area between from 0 to 1, we know is 34%. We want to calculate what the z-score is. How do we do that? We say, so we go this integral with the equation e with respect to x. And okay, all right, we know that it's going to go from 0 to some number. So this is going from 0 to some unknown a. All right. So, okay. What you want to do is you go algebra, solve, and then you take this definite integral. It's going to be some function of a, and you set it equal to the 34, right? You know the area. That's the idea. And we want to solve for a, and there it is. A is it's 1. It's 0.994 because that's not the exact value. If you have to go to the table and get the exact value, or if we the actual area between 0 and 1 is this. So if we did 34.1345, there you go, 1. You see, if we wanted to calculate, so we have the area between 0 and 2, we know is 48%, so we would solve is equal to 48. Solve for a. There it is, 2.05. Why is it not exactly 2? Because you have to get the exact number. There you go. So if we put that in, 47.725, we get 2. Okay. Let's look here. The area between minus 2 and 1. But let's assume you know one of the numbers. You know either minus 2 and you don't know the upper limit, or you know 1 and you don't know the lower limit. Okay, so all right, the area is 82%. let's say you don't know the lower limit, but you know the upper limit. So you put 1 here and you put a here. There it is, minus 2. It gives you the lower limit, and you could do the same thing in reverse. This one here, you could take advantage of the symmetry. You know that 2 times this area. So, I mean, you don't have to use the symmetry. It'd just be a little more complicated to do this, but you would say, okay, so from all right, you could, so let's take this. This is going to equal 82, and you don't know. Yeah, now you could put it, okay, put 2 here because it's going to be symmetric. So 2 times this is equal to 82, and then what is this? So this goes from 1, or no, we don't know this, a to infinity. Or you could do minus the other way, from minus a to negative infinity. This is going to be 1. Or no. Oh, no, I see. This is 32%, not 82. There you go. See? Now, for this situation, it's not as simple. If you, let's say it is simple if you know either one of these boundaries, right? And you're trying to solve for the other one. But if you don't know either boundary, what I tried doing was, what I was hoping would work is, so the area between 1 and 2 is about 14%. So I tried to make this 14 and then do like from A to B and then solve for A or B, and then you could get, I was hoping you'd get some expression of A and B, and then with that you could kind of see what the constraints of A and B are, but it doesn't give you that. But it would be, even if you did have an expression for A and B, the idea is you choose an A and you see what B is, which is, you could do that starting from here anyway, right? You could choose a B and see what A is. Choose another B. See what A is, or vice versa, right? So you could play with it that way. Okay. So, all right, the area between plus or minus what under the normal curve equals 68%. This is easy. We say it's going to be one number. So what we do is you solve for, wait, no. Take the, so all right, and this is going to go from minus A to A. Okay, now, no, we want to solve this is equal to 68 for A. 1. All right, what about 75? $1.15. That easy. The normal curve is sketched below. Solve for Z. Okay, we just did this. Just change this to 90. $1.64. Z is equal to 1.64. All right. What about this? Easy. We do, this is going to go to minus infinity. The A is the Z. This is the A. Maybe I should have just put Z. Yeah, I should have been putting Z. And then this is equal to 90. 1.28. All right, a certain curve, not the normal, is sketched below. The total area under this curve is 100%, and the area between 0 and 1 is 39%. If possible, find the area to the right of 1. So these last two problems, it wants us to practice kind of visually estimating an area. And they talk about this in the section for the idea of finding the area between 1 and 2. You couldn't do it with the tables, and so you have to use that guess kind of estimating method, which using the calculator avoids having to do that. But let's still work these problems just to practice this. I mean, it can be good practice. You know, like something like this is not the normal curve, so we can't use a calculator anyway. So the area to the right of 1. So if the area between 0 and 1 is 39%, and they want to know the area to the right of 1, that's just going to be, and we know the total area under the curve is 100%. Well, 100 minus 39. I don't need to guess the area. This is going to be 100 minus 39, 61%. If possible, find the area between 0 and 0.5. Okay, so this area. We know the area between 0 and 1 is 39%. I mean, it's impossible to get the right answer, because the exact correct answer, because we don't have further information. But could we potentially kind of guess this? Well, if this is 39%, this is going to be close to 39%. It looks like it's going to be a little more, because the curve doesn't just continue like that. It's not, if it was symmetric, it would be like that. There's a little bit more. So I would say, well, all right, this total area is 39%. So 39 divided by 2 is 19.5. This is so I wouldn't say that this is 19.5 and this is 19.5. I would say like this is 22 and this is 17, something like that. Maybe even 21. This is 21 and this is 18. That's a good estimate. I'd say 21%, right? Because this total area is 39%, and they want this area, and so if this total area here is 39%, you draw a line down the middle. It's not quite cutting this in half. This is a little bit more than this. Half would be 19.5, 19.5. So I would say this is 18, this is 21. So I would say 18%. That should be in the ballpark. A certain curve, not the normal, is sketched below. It is symmetric around 0, and the total area under it is 100%. The area between -1 and 1 is 58%. If possible, find the area between 0 and 1. All right, so, yeah, I mean, this is good practice. This is, you can still, even with the calculator, using the calculator, you can use the symmetry to help get areas. So if the area between -1 and 1 is 58%, it's telling us this curve is symmetric about 0. So since that's the case, the normal curve is symmetric about 0. And so if that's the case, if the area between -1 and 1 is 58%, then the area between 0 and 1 is half of this. What's half of 58? 29. If possible, find the area to the right of 1. Okay? We know that this is 29%. We know that all of this is 50%. So the area to the right of 1 is going to be 100 minus what? 50 plus 29. So let me get rid of 100 minus 50 plus 29. If possible, find the area to the right of 2. Well, yeah, we don't know because it only gives us this information, but we could, if we had to guess, if this area is 29%, then what would this area be? Half of that? Maybe so. So if this is 15%, so what is 15 plus 29 plus 50. 15 plus 29 plus 50. This is 94. So what's 100 minus 94? 6. So that would, if you had to get a rough estimate, you'd say 6. I mean, you could, if you had to, if it was that important and you knew this histogram was drawn to scale, you could get like Photoshop out or like the paint in Windows and really look at this and okay, like see like how much smaller is this area than this area? You know, you could, you know, if you had to, you could do that. Okay, so that's it for section 5.2. Let's move on to section 5.3.